Welcome back, welcome back, welcome back. I'm Lisa Blackburn, and this is my YouTube channel for everything I want to talk about science and math. And this is to help my chemistry class with their homework, where they are having to write and balance chemical equations. So if you look at your homework, the first page is single replacement reactions. Find that one. Okay, and so on it, you've got silver plus potassium nitrate. And this is single replacement, and we want to see, does silver replace potassium? So we have to go to our strength chart. So I included this on this lesson. It's on your canvas, and what you're looking for is this page with the cat right there, super cat, doodle-doo, more fun with sound effects. So you look to see which one is on top, potassium or silver. Well, silver is way down here at the bottom, and potassium is way up here at the top. So silver cannot replace potassium. So we would write NR, no reaction, which I remember when I took chemistry, I always thought was fun when I got to say NR, no reaction, because that means I didn't have to do it. Okay, so now we'll try the next one. Zinc, can zinc replace silver? We look back at the chart, doodle-doo. Silver is way down here, zinc is up here, so yes, it'll happen. So silver is going to go off by itself, and then zinc is going to replace the nitrate. Well, this goes back to our last test where we have to figure out the charges. So zinc is +2, and nitrate, you look it up in your polyatomic ion sheet, is -1. So when it gets together, it's ZnNO3 taken twice. Remember, crisscross applesauce, ka-ching. And then, so the 2 goes down there, the 1 there. And now we would balance it. 1 zinc on this side, 1 zinc on that side. 1 silver on this side, 1 silver on that side. But 2 nitrogens on this side and only 1 on that side. So we're going to have to go and put a 2 over here. I'll change to another color so you can see it better. We'll make the balancing blue. We're going to put a 2 right there, so now there's 2 nitrogens. And now there's 2 times 3 is 6 oxygens, 2 times 3 is 6 oxygens. But now we have 2 silvers over here, so we needed 2 right there. All right, so now go to the next page. Mine's up. Oh, let me undraw it. I'll put it on home and see if I can scroll. Nope, I'm going to have to go over here. Hold on, it'll be worth it. I got to scroll on the big computer here. There we go. Okay, so now turn it over to the other side that's double replacements. And how you tell with double replacements is the other sheet I gave you that have the solubility rules. And we have a little pig that tells you the solubility rules. He's saying nag-sag. And the soluble things are nitrates, acetates, and things from group 1, sulfates, ammonium, and group 17. Nag-sag. So there's our pig. But this page right here tells you if things will actually react or not. Will they do a double replacement, or is their love true and are they affair proof? Okay, so where it doesn't work is where they are all soluble. So if you look in your notes, number 5 doesn't work because they're all soluble. None of them become a solid and precipitate out. So what's happening is in here that they are all just floating along like ions and nobody really gets together. This is a singles party where they're all dancing and having a good time, but nobody's really pairing up, okay? So I want you to look at the sheet and see if you can figure it out by looking at the solubility rules. We'll talk about more, but 1 through 4 will double replace. 5 doesn't double replace, 6 or 7. And then 8, 9, and 10 do double replace. So see if you can look at those solubility rules, see if you can figure this out. This is definitely something you'll do in college. Okay, and then the other page is combustion reactions. Anyway, for the combustion reactions, they will all work, they all burn. And so for each one, you write down the chemical, you write down O2 for oxygen, and then for your products, you do carbon dioxide, water, and energy. So we do the combustion reaction just like it's in your notes for all of them. So this is the easy one, the combustion one. Now, we're going to just assume it's all complete combustion, that's perfect amount of oxygen and all that. So for each one, if you can see mine, whoop, there's the key. You can see that for each one, I wrote the chemical that they've got, then plus O2 yields CO2, H2O, and E. And you don't have to do anything with balancing the E. But those are pretty fun to balance. So give your homework a try. These are some of the harder ones because you have to predict the reaction. Science is great. See you soon.